So today we're going to be talking about more transformation. So we did in day one and talk about reflections. You can hear our cat. She's screaming. Reflections. Um, and that would be when you reflected across vertical or horizontal or slanted. And so you learned about 3 formulas with that. Come here, kitty. And so she's screaming. You might hear her. So we did reflections and we're going to do translations today. And then we're going to do rotations tomorrow. And so isometry is transformations that don't change the shape or size of a figure. And so when we look at those kind of transformations, the beginning and ending figures are going to be congruent. And so we can write that down. They're going to be congruent. And so the pre-image and the image are both congruent. These are called, and they're called rigid, okay, rigid motions or rigid transformation, RIGID, okay, if I spell right, and then or congruent transformation. I'm going to use this symbol because I'm pretty zoomed out, and so it's kind of small to right there. But those are some ways to talk about isometry, is to be like, hey, the beginning and end shapes are going to be congruent to each other. And so today's shape is called translation. TRANSLATION. It's a little hard to read, and I should probably zoom in so you can see it better. Okay. And that's a function in which all of the points, points on a shape. So every single point on a shape gets scooched, over a bit. Okay. And that's so not true, but it is in a most basic way. Absolutely. Every single point on the shape, whether it's a triangle, gets moved the same distance. Okay. And in the same direction. So if I take a triangle and I'm going to ship this whole triangle, to Bermuda. Okay. Well, awesome. Let's send this triangle to Bermuda. They don't have enough triangles there, just kidding. And so we send this to Bermuda. That's the direction towards Bermuda, and the distance is, however many miles that is. Now, if you send part of your triangle someplace and part of it someplace else, well, that's not going to make a current shape. So again, every single point on the graph has to go the same direction and the same distance. And then they kind of congeal there and say, hey, look that's my resultant shape. And so we can kind of look at this and say, okay, translation vectors kind of boss things around and say, hey, this is where we're going. And so what do you mean boss it around? Well, they point. Like if you've got a, boss, you go that way, maybe in PE, they tell you how far to go and in what direction, right? So if you've got a pre-image right here, that's the original image. And notice these arrows over here. These arrows say, hey, go this way, go this far, go in this direction. So each point goes in this direction and this far, the length of the arrow. And so every single point goes there, every single point goes that direction. So notice what you end up with is your image or your resultant shape that is going to be congruent to the original, and it's going to be transformed or translated, that direction for that distance. And so we'll practice below. You'll kind of see that below, be like, look at this shape. What do they want us to do with this square? They want it to go kind of diagonalish and about the length of this arrow. Okay, and so the length of the arrow says how far to go. The arrow pointing says which way to go. And so again, without a graph, the arrow shows two things. It shows you the magnitude, which is the length or how far you go, and then also the direction. Okay, if you've heard the word magnitude, like that's a huge magnitude that we dropped a atom bomb on Hiroshima. Yeah, that's huge. So the magnitude is the size of what you're doing. Okay, how far you go, and the direction is going to be the which way you go. Now on a coordinate plane, I want you to kind of focus on over here where it's like, okay, which one's the beginning of the pre-image? And if you look carefully, this purple one has to be the pre-image because all of the points don't have a prime on it. So those are the beginning values. And then this right here is going to be the image or resultant shape. And so when I ask people like, hey, how far did this graph move to go, the shape move, to go from the point A to point B, to go from the beginning to the end, the pre-image to the image? And they're like, 3? Because they see the distance between. No, the answer is no, actually not. You look at a point, okay, and you find its corresponding point. You say, how far did that actual specific point go? Because we're trying to figure out how much did every relative point to each other travel to get from point A to point B. And so it looks like if you count, they went 1, 2, 3, 4, 5, 6, 7, 8, 8 to the left and 2 up. And this form right here is called vector form, and this is what you use on a graph because it's hard to describe diagonally. You got to use the Pythagorean theorem if you want to actually figure out that. So instead, we break it into the horizontal and vertical components. The horizontal part goes in the first one. So this is horizontal. The x value, basically, how far it goes left to right. So like left is negative and then right is positive. And then this is going to be the vertical, the y. And that tells you like up is positive, make a plus sign, and down would be a negative. And so on this one, you go left 8. So you would go negative 8 and you go up 2. So you would do a positive 2. And you put it in these little, I don't know, these angular things. These angular things, hey, that's not a point, that's a direction, that's a vector to say, hey, take your point and shove it left 8 and up 2, and that's how you get from point A to point B, from your pre-image to your image. And so, as we're, doing this on patty paper, again, whenever you don't have a graph, use your patty paper. And how you do this, it says the directions here, use your tracing paper to place the paper over your original shape. And, if you see a patty paper on there, you would take that, or the parchment paper. You mark each vertex on the patty paper, and you also would mark your arrow, okay? And that's your vector arrow. And you want your whole graph to shove this way, like this length of this arrow. And so how you do it is you kind of pick up your paper, and underneath it you kind of either use gooey pen, you know what I'm talking about, or use like pencil, so that when you replace this here and then you slide it diagonally and until the end of the arrow reaches here, so you've got kind of like another arrow here, you will be able to place this new shape by marking on these vertices, and you'll say, okay, well, this would be D prime, this is C prime, this is B prime, and this is A prime. And yes, you'd use a rule and make it cute. So again, how do you do it? You mark the vertices on the top of your parchment paper, and you also mark this, which is be really careful with how long it is on both sides. You lift up your parchment, holding your hand, and mark on the back of the parchment where these vertices are, and you can use kind of like put some lead there or put like some gooey pen, and then you basically slide it diagonally so that the end of your vertex kind of matches here. So slide it this way, and when you do that, you will notice that you'll mark on your triangle, and then you'll connect the dots. You'll say, hey, look, I moved A prime, B prime, and C prime. I moved my graph diagonally this distance by using patty paper, or using parchment paper. And so it's kind of cute, where yesterday you picked up your parchment paper, you flipped it over, and then made a mark. And so that was how you reflected things. Here we're sliding it. And so it's kind of cool to see, how would you slide this when you don't have graph paper to kind of count the distance that you're traveling to get there. So it's kind of cool. When you do have graph paper, you're going to see this vector. And again, we already talked about the vector tells the horizontal and vertical component. The horizontal goes first. Okay, so let's mark that. The horizontal is the A value. And again, right and left, it's going to be positive, it's going to be to the right, and negative, it'll be to the left. And then the second part would be B. And again, the B value represents how much up or down each point would go. So when you read this, you say, okay, I'm going to start with this point right here, and I'm going to do this for this vector to it. So, okay, so if you start with the X value and you put a 7 with it, so -2 was 7, is going to give us 5. So because -2 plus 7 is 5. And then if you take the Y coordinate with the Y value of the vector, 3 and 4, that gives us 7. So truthfully, to go from point A to point P to P prime, you're going to start at -2, 3. You're going to end up at 5, 7. Notice by way of saying, let's move to the right 7 and up 4. So counting wise, you'll notice that happens as well. So the vertex, not the vertex, but the vector has us move a specific direction, and this is the X and the Y components. And so you place those with the X and Y points. So let's try looking at a couple specific examples here. So the first one is kind of review, like, okay, can you tell which one of these is a reflection and which one's a translation? Okay, and if you look, you notice that the second one is a reflection. And it's a reflection about this vertical line of X equals 1. And notice every point on the first graph, the pre-image and the image is equidistant from that line of reflection. So point J is 2 hops away, and so is plot J prime. K and K prime, I can't talk, are going to be equidistant as well. And so this is going to be a reflection across the line Y, X equals 1. So sometimes we do it across a line, sometimes we do it across the X-axis or the Y-axis, or just even the equation Y equals X. On this one, I asked my classes, and they kind of knew and kind of didn't actually, which one's the pre-image, and which is the final result. And if you zoom in, you'll see this is the pre-image because it doesn't have any primes on it. And then, so the question is, how do you get from this E to this E right here? And you got to focus on corresponding points. They'll be like, how do you get there? Well, I see that you go this way, and then you go down. Okay, and so it looks like you're going left 1, 2, 3, 4, and down 2. So if you go left 4 and down 2, left 4 and down 2, how do you write that in a vector 4? Okay, so you put your little V's out. You're like, okay, left 4 would be -4 because this is left or right, and this is up or down. Okay, and so then it's down 2, so it'd be -2. So that would be my vector, left 4 down 2, to get from the beginning to the end. So again, you got to know where to start, and you got to read the directions and look at the points, be like, oh, I see that. And so, in your homework, I'm going to say, okay, well, let's look at some of these items, where it's like, okay, we've got a pre-image of A, which is -4. Okay, that's A. And then B is -2, -3. And then C is -1, 3. Not C. And so if you use a ruler, which you really should, because things will look a lot better. And you'll be able to tell if they're congruent, and it's just kind of how we play the game. But I'm using a smart board, so it's a little hard to do. So the translation formula they ask us to, because we're using a grid, is to use this vector here. It's 5, 2. And so as we do this, the x's go together and so do the y's. And so you put the x coordinate with this x value of the vertex, and they'll put the y coordinate with the y coordinate of the vertex, of the vector, to get our point. So, okay, let's do this. Okay. So if we take -4, which is the x value, plus the 5, and then, okay, that'll give us 1 for our image. Then we take -4 and 2. So you take -4 plus 2, again, the y coordinate with the y vector value. And that gives us -2. So in fact, our A prime would be as shown. Our B, to get our B prime, well, you take our x coordinate and you put it with the x value of the vector. Okay, so again, we're trying to move it right 5, so we're going to plus 5 to it. And then we take -3. We're going to plus that, -3, yeah. We're going to plus 2 to it. Again, the y value and the y component of the vector. And so our B prime, our second point, would be 3 and -1, okay? And then to get the value for C, we're going to take the x coordinate with the x value of the vector. And so it'd be -1 plus 5. And then we do 3 plus 2, again, the y coordinate and the y value from the vector. And so C prime should be 4 and 5. Okay, so let's graph them and see what happens. If you notice something dumb happens, you might have done some dumb math, or you might have plotted it wrong. So look at it. You can kind of see, did every point look like it moved to the right 5 and up 2? And so 1, -2, they have that as A prime. And then 3, -1 is B prime. Looking good so far. And then C prime is 4, 5. 1, 2, 3, 4, 1, 2. And so this is C prime. Let's see how that looks. And if you look, yeah, they look congruent. And also if you take a point, 1, 2, 3, 4, 5, up 2. Hey, look, that at least point B went right 5 and up 2. So it followed the rule that we were trying to, the vector is bossy. It says how far to go and in what direction. And so whether it points or it tells it algebraically, like on a graph, that's what you're looking to do. Okay, let's keep going. And then below here, we've got yet another graph. So if we graph the pre-image, we can plot 1, 0, that's P, and we can plot 2, 2, that's E, and then N is for 1. We're going to get a pentagon, and so it's kind of cute. 4, -1, T, and then A is 2, -2, cute. So you connect these dots. Yeah, let's use a straight edge. And then, okay, we got to do a translation with it. Okay, the translation says it's according to the vector shown above. Look at that cute little vector. The x component says go -5, and the y coordinate says go -1. So we're going to go take this graph left 5 and down 1. Okay, and so how do you get these answers? Well, we put the x's together and put the y's together. So this is 1 - 5. That's the x values, and then 0 - 1. That is -4, -1. So that's a prime. No, it's p prime, penta. Okay, and then the next one is 2 plus -5. And then 2 - 1. You can put in plus and negative, doesn't matter. So e prime would be -3 and 1. And then n is 4 - 5 and 1 - 1. So you get -1. And we also get 0, cute. And then 4 - 5 again, still -1, and then -1 - 1 is going to be -1, and then -2, and then that's going to be n prime, t prime, and then a prime would be 2 - 5 and -2 - 1, which is -3 and -3. Okay, cute. And so let's try graphing these little suckers. Okay. So to plot p prime, it's -4 and then -1, that's p prime, and then -3 and -1. It does not look right. Okay, and -3 positive 1 would be what we actually have. -3 positive 1 would be e prime, and then let me erase this here. Let's see if I can erase it. Not well. Okay, and then n is going to be 1 -1 0. Okay, n prime, and then t is -1 -2, t prime, and the last one is -3, 1 2 3 1 2 3, cute, a prime. Okay, connect the cute little dots. I'm looking to see, does every point go left 1 2 3 4 5 and down 1? The answer is of course it does. So focus on the a's maybe. Okay, to get from 1a to the next, you would travel left 5 and down 1. So your vectors should make sense with your final graph. They also should be congruent, and it should make sense. Okay, so if you see a picture, wisdom says you should be able to say which one's first. Okay, well, this is the pre-image, so you can call it A, B, C. How do you know? It says the shaded, is it? Well, then this is the baby, the A prime, B prime, and C prime. Again, call it whatever you want, but how do you get from the corresponding parts? So label those, and you're like, okay, I go up 1 2 3 4 5 and left 1. Well, left 1 and up 5 is going to be -1, and then 5 go like this. Okay, so the left to right goes first. Again, left is negative, the up 5 is second. Okay, so over here, if you put this in, you're like, okay, A, B, C, D. That's the pre-image, and then the image is A prime, B prime, etc. So what happened? Well, think about it. Look at your C's and be like, okay, it looks like I went 1 2 3 4 5 6 up 1 2 3. So right 6 up 3. Okay, left and right goes first. So you got +6. Up 3 is a positive this, and so 6 3. Over here, you got to use your tracing paper because we don't have a grid to measure what we're doing. And so we use the tracing paper to help us to say, how can you navigate these things? So first thing is to reflect it. And so how do you reflect it? Well, you place a piece of sketch paper with this and you mark these guys here. And you mark this. And then you flip it on its tummy and line up this line of reflection. And then when you place it on its tummy over here and draw on those values, you should get, trying to picture it in my head, be like, what's this going to look like? And so, because I don't actually have the paper in front of me, so here we go. Okay, so we've got the shape. This again would be G prime, and this would be F prime, and this would be H prime, and this would be E prime. And then we want to slide it. So again, now you place your tracing paper on here and trace these vertices. And you say, okay, and you trace this right here. You slide your shape this way till it matches the end of it. And then you will get, I believe, something that looks like this. And this would be E double prime because it's a second iteration. You get G double prime, you get H double prime, and you get F double prime. Kind of cute.